It is the most primal human impulse, not to fly but to arrive, to collapse the agonizing empty spaces between here and there, to erase the waiting, every red light, every delayed train, every moment staring at a progress bar. They are all tiny echoes of a much greater frustration, a cosmic impatience encoded in our very being. We are a species that looks up into the velvet black of night. We see a billion destinations, a billion suns, and we are trapped by a tyranny of distance so profound it mocks our ambition. Our fastest probes, the pinnacle of our ingenuity, are cosmic snails. They would take 75,000 years to reach the very next star. 75 millennia of silent coasting through an unforgiving void. A journey so long that when it arrived, the human race itself might be a forgotten myth. This is our reality. A magnificent celestial ocean, and we are marooned on a single shore. We are prisoners of the cosmic speed limit. But what if we weren't? What if, in a hidden laboratory or a flash of divine insight, we found a loophole? Forget the how. That is a story of engineering, of thrust and fuel. Let's embark on a far more dangerous thought experiment. Imagine not the decades of construction, but the final gleaming result. A vessel poised at the edge of our atmosphere, inside a single switch, a simple toggle from off to on. But this switch does not ignite a rocket. It engages the impossible. It commands the universe to bend. What if today, right now, we could flick that switch and travel at the speed of light? The journey would not begin with a roar, but with a silent shearing of reality. One moment, you are tethered to Earth, a blue marble filling your view. The next, you are moving at nearly 300,000 kilometers per second. The universe, as you know it, ceases to exist. The familiar constellations of your ancestors are gone. They do not streak past you like in our fictions. They warp into a terrifying, unfamiliar architecture of light. Ahead of your ship, the stars collapse into a single brilliant point, a searing tunnel of white-hot radiance. The Doppler effect, a phenomenon we hear in a passing siren, becomes a cosmic weapon. Starlight rushing toward you is compressed, its wavelength shortened. Visible light becomes X-rays. X-rays become lethal gamma rays. The forward view is no longer a window, but a particle accelerator's beam port, a torrent of deadly radiation incinerating anything in its path. Looking back, the opposite happens. The light from the sun from your home is stretched into oblivion. Its warmth and color descend through the spectrum, from yellow to red to infrared, and finally to the cold whisper of radio waves. The Earth doesn't shrink behind you. It simply vanishes from sight. It fades into a silent, undetectable memory. You are flying blind in a universe that has become utterly alien, a cosmos of lethal energy ahead and absolute blackness behind. This is merely the first distortion in a journey that unravels everything we are. The true paradox is not what you see outside the ship, it is what is happening to you, to your perception of time itself. Albert Einstein's great insight was that space and time are not separate. They are a single unified fabric spacetime, and your impossible speed is tearing a hole right through it. As you approach the speed of light, a strange alchemy begins. The universe begins to pay you for your velocity with the currency of time. From your perspective inside the vessel, the clocks tick as they always have. Your heart beats in its familiar rhythm. Your thoughts unfold at their normal pace. But outside your ship, eternity is unspooling. For you, a journey to Proxima Centauri, our nearest stellar neighbor, is instantaneous. You flick the switch, and you are there. Zero time has passed. You have crossed 4 light years in the blink of an eye. A perfect, instantaneous arrival. The ancient dream fulfilled. You have conquered space, but you have become a victim of time. Imagine that voyage, a quick scouting mission. You depart Earth on a Monday. You arrive at Proxima Centauri moments later. You orbit a new world, you gather your data, you witness alien sunrises. You spend a week by your ship's calendar exploring this new frontier. Then, satisfied with your historic achievement, you turn for home. The return journey is also instantaneous. You leave on a Monday, and you expect to arrive back on Earth on a Monday. But the Earth you return to is not the one you left. While a single week passed for you back home, more than 8 years have elapsed. The friends who toasted your departure are nearing a decade older. The children who waved goodbye are now teenagers, their voices deeper, their faces changed. Your entire life, your world has moved on without you. The news cycle that followed your launch is ancient history. Governments may have changed. New technologies may have rendered your mission obsolete. You are a hero, perhaps, a ghost most certainly, a time traveler cast adrift into a future you did not ask for. This is the profound covenant of light speed. It offers the universe, but it steals your timeline. Every journey becomes a one-way ticket to the future. A round trip to the Andromeda Galaxy, 2.5 million light-years away. For the traveler, it could be a month-long expedition. You would return to an Earth 5 million years older than the one you departed. Humanity would be an entirely different species if it existed at all. The continents would have drifted. The mountains you knew would have eroded to dust. You would be an artifact of a lost epoch, a fossil in your own lifetime. This isn't a theory or a whimsical speculation. It is a fundamental consequence of the way our universe is built. We've proven it. Atomic clocks on supersonic jets tick slower. GPS satellites must constantly adjust for this time dilation. The effect is real, and at the speed of light, it becomes absolute. To travel at light speed is to watch the universe age in fast forward. You become a godlike spectator, witnessing the birth and death of stars in moments. But you can never go home, not to the home you remember, not to the time that belongs to you. But the universe has even stranger defenses against this ultimate velocity. Time is not the only thing that warps and bends. So does the very substance of your ship, your body, your atoms. Another of Einstein's revelations connects energy and matter. Mass is simply a form of concentrated energy. To make something move is to give it kinetic energy. As you accelerate, you pump more and more energy into your vessel, and that energy adds to your mass. At terrestrial speeds, the effect is imperceptible. A speeding bullet is not measurably heavier than a stationary one. But as you climb toward the speed of light, the numbers become astronomical. At 80% of light speed, your mass has almost doubled. At 99%, it's 7 times greater. At 99.999%, you are over 200 times your original mass. Your starship, once a sleek vessel, now has the mass of a small asteroid. The closer you get to that absolute limit, the more stubborn the universe becomes. Each new increment of speed requires an exponentially greater amount of energy. The cosmos itself is resisting you, its laws stiffening against your assault. To reach the actual speed of light, 100% is to cross a final barrier. At that precise velocity, the equation predicts your mass becomes infinite. Your ship would become heavier than all the galaxies in the universe combined. And the energy required to move that infinite mass, it would also be infinite. You would need all the energy that has ever existed or will ever exist just to make that final push. The speed of light is not just a number. It is a cosmic horizon, an asymptote that can be approached but never ever reached by anything with mass. It is the universe's most fundamental law. Thou shalt not travel at the speed of light. It is the boundary that protects the sequence of events. It is the wall that separates cause from effect. To break it would be to shatter the logical foundation of reality, and yet our thought experiment demands we do. We flick our imaginary switch, and we bypass this infinite wall. We ignore the paradoxes of time and perception. What would such a power do to us as a species? The moment that first light-speed journey is confirmed, humanity is reborn. Our entire civilization is built on the concept of distance of scarcity. Light-speed travel demolishes both. Borders between nations become meaningless lines on a map. Why fight over a patch of desert on Earth when you can be on a pristine Earth-like world in what feels like an afternoon? The entire economic model of our planet would implode overnight. Resources are no longer finite. There are entire planets made of diamond oceans of liquid methane, mountains of gold. An asteroid belt in a nearby system could contain more precious metals than have ever been mined in human history. Who owns these worlds? Who has the right to claim them? The first nation, the first corporation to master this technology, would become a true empire, a dynasty against which all others are powerless. They could evacuate their entire population to a new star system. They could wield resources on a scale that is for us mythological. It would trigger a gold rush so vast it would make all others in history seem quaint. A frantic, desperate scramble for the stars, redrawing the maps of power, not on a continent but across the entire galactic arm. Our sense of self, our philosophy, our religions would be fractured. For millennia we have defined ourselves as the sole inhabitants of our world, the central figures in a divine or cosmic drama. Light-speed travel ends that comfortable solitude. We might find that the universe is teeming with life, or we might find that it is terrifyingly empty. Either discovery would force a spiritual and intellectual reckoning. Are we one of many, or are we a staggering, lonely miracle? The ability to travel to the stars offers a new kind of immortality, not of the body, but of the species. We would no longer have all our eggs in one fragile terrestrial basket. A supernova, an asteroid, a self-inflicted catastrophe on Earth would no longer mean the end of the human story. It would be a tragedy, yes, but not an extinction. Humanity could spread, diversify, evolve down different paths on 1,000 different worlds. We would become something new, post-human, galactic. But this diaspora creates its own schism. The traveler for whom the journey is instant and the homebody for whom centuries pass. These two branches of humanity would become unsynchronized. They could no longer communicate in real time. A message to a colony 10 light years away would take 10 years to arrive, and another 10 for a reply. Cultures would diverge so completely they would become alien to one another. They might even forget their common origin. The instantaneous ship creates a fractured, time-dilated civilization, a network of colonies separated not just by space but by insurmountable gulfs of time. This single impossible switch doesn't just give us a faster ship, it breaks physics, it shatters economies, it rewrites what it means to be human. It is a power so immense it forces us to confront the most fundamental questions. Are we ready for it? Is such a discovery a key to our salvation, or a trigger for our self-destruction? The journey to the speed of light is not a voyage through space. It is a journey into the very nature of reality itself, a place where time behaves like a dream, and the universe reveals its deepest secrets and its most unforgiving laws. Join us as we defy the infinite. We will navigate the paradoxes and explore the consequences. We will step aboard a vessel of the imagination and ask the ultimate question. Not can we travel at the speed of light, but what happens to us when we do? Every time you move, you are whispering a secret to the universe. Every step you take, every turn of a wheel, every beat of a heart, you are participating in a conversation about space and about time. For most of human history, we thought we knew the language. We believed that speed was simple, a matter of effort. Push harder, go faster. There was no conceivable boundary, no ultimate finish line you could not, with enough power, cross. The universe was a vast, silent stage, solid and unyielding, a backdrop of absolute space and a river of absolute time. A clock in London ticked at the same rate as a clock on Mars. A meter stick measured here was a meter stick measured anywhere. This was the cosmos of Isaac Newton. Orderly, predictable, sensible. In this universe, speeds just added up. Imagine you are on a train moving at 100 kilometers an hour. Inside your carriage, you throw a ball forward. You throw it at a gentle 20 kilometers an hour. To someone standing by the tracks watching your train rush past, the ball's speed is not 20, it's 120. Your speed plus the ball's speed. Simple, obvious. It's a rule so intuitive it feels woven into the fabric of reality. And for centuries we believed this rule applied to everything, to cannonballs, to planets, and even to the fastest thing imaginable, even to light itself. We thought that if you could somehow race alongside a beam of light, it would appear to slow down just like the ball on the train. If you could build a starship that traveled at half the speed of light and you switched on your headlights, that beam would shoot away from you at only half of its normal velocity. It made perfect sense. It was the bedrock of our understanding, and it was completely, profoundly, spectacularly wrong. The first crack in this perfect clockwork universe was not a thunderclap. It was a whisper, a mathematical oddity buried in equations. In the late 19th century, the great physicist James Clerk Maxwell unified electricity and magnetism into a single elegant theory. His work described a universe filled with invisible waves. And one of those waves, born from oscillating electric and magnetic fields, traveled at a very specific, very stubborn speed, roughly 300,000 kilometers per second, the speed of light. But here was the puzzle, the clue to a much deeper mystery. Maxwell's equations didn't say what this speed was relative to. It wasn't 300,000 kilometers per second relative to the Earth, or relative to the Sun, or relative to the source that emitted it. It was just 300,000 kilometers per second, an absolute cosmic constant. This was heresy. It violated the simple logic of the train. It suggested that if you were on that starship, no matter how fast you flew and you switched on your headlights, that beam would still race away from you at the full, undiminished speed of light. It was as if the person on the tracks and you on the speeding train both saw the ball you threw moving at exactly 20 kilometers per hour. An absurdity. A paradox that threatened to unravel physics. Scientists were convinced there must be a mistake. They proposed a ghost in the machine, an invisible medium filling all of space. They called it the luminiferous ether. Light, they argued, must travel through this ether-like sound, travels through air, or a ripple travels through water. The Earth itself must be moving through this cosmic ocean, and if it was, we should be able to measure the current. A beam of light sent out upstream against the ether wind should travel slower than a beam sent downstream. Two American physicists, Albert Michelson and Edward Morley, set out to measure this ethereal wind. They built one of the most sensitive experiments in history, an intricate device of mirrors and light beams designed to detect even the slightest change in light's velocity. They split a beam of light, sending the two halves on perpendicular journeys and then bringing them back together. If one beam was slowed by the ether, the reunited waves would be out of sync, creating a telltale interference pattern. They performed the experiment, they refined it, they repeated it, and they found nothing. Absolutely nothing. The speed of light was stubbornly, maddeningly, precisely the same in every direction, at every time of year. It refused to change. Physics was at a breaking point. The experiment was a failure. The ether, it seemed, did not exist. The universe was not a placid ocean. It was something far stranger. And the paradox of light remained a cosmic crime scene with no suspect. until a young clerk in a Swiss patent office dared to think the unthinkable. Albert Einstein was not a mainstream physicist. He was an outsider, a dreamer who spent his days reviewing inventions and his nights wrestling with the very nature of reality. Where others saw a contradiction, a flaw in the laws of nature, Einstein saw a profound and beautiful truth. He asked a different question. What if the experiment wasn't wrong? What if the speed of light really is constant for everyone? What if that is the one unbreakable rule of the cosmos? If that were true, he reasoned, then something else must be giving way. Something we thought was solid, absolute, and unchangeable. And that something was space and time itself. This was his leap of genius, a moment that redefined our world. Einstein proposed that space is not a rigid stage and time is not a universal river. They are a single interwoven fabric, spacetime, and this fabric is flexible. It can stretch and it can shrink. It bends and it warps to ensure that one law remains sacred. The law that light in a vacuum always travels at the same speed, for every single observer, everywhere, all the time. From this single revolutionary idea, a new universe was born. A universe of bizarre and wondrous consequences. A universe where our most cherished intuitions about reality fall apart. The first casualty of this new cosmos was our concept of time. Imagine two twins. One stays on Earth, the other boards a hypothetical starship, a vessel capable of incredible speeds. The ship accelerates, pushing ever closer to the cosmic limit. As it does, something extraordinary begins to happen. From our perspective on Earth, looking in time on that ship slows down. The clock on the wall of the cockpit ticks more slowly than ours. The ship's computers process information at a reduced rate. Even the astronaut's heart beats at a slower rhythm. This isn't a mechanical failure or an illusion. The very flow of time inside that spacecraft has been altered by its motion. The universe is enforcing its primary law. To keep the speed of light constant, for the traveler, time itself must yield. It must dilate, must stretch to accommodate the ship's velocity. The faster the ship goes, the more dramatic the effect becomes. At 87% of light speed, time for the traveler flows at half the rate. For every 2 years that pass on Earth, only 1 year passes on the ship. At 99.5% of light speed, 10 years on Earth would feel like just a single year for the astronaut. If our traveler journeys to a nearby star and returns, decades may have passed for the twin left behind. Friends and family would be older. The world would have changed. But for the traveler, it may have been only a few years. They would have journeyed into the future. This isn't science fiction. It is a fundamental feature of our reality. We have measured it. Every day, the GPS satellites orbiting our planet must account for this effect, this time dilation. They are moving much faster than we are on the ground. Their internal clocks run slightly slower than ours. If our engineers didn't correct for Einstein's relativity, your GPS would become inaccurate by kilometers every single day. Time, the great constant, is in fact personal. It is relative. Your speed through space dictates your speed through time. But time does not warp alone. To preserve the constancy of light, space must also transform. As our astronaut's ship accelerates, not only does time slow down, the universe in front of them begins to change its shape. From the traveler's perspective, the distance to their destination shrinks. Space itself in the direction of motion contracts. A journey of 4 light years to the nearest star system, Alpha Centauri, would for someone on the ship traveling at near light speed appear to be a much shorter trip. The cosmos ahead quite literally flattens. Stars would appear to shift, their light blue shifted and intensified. The very geometry of the universe warps around the traveler. This is not an optical illusion. For the person on that ship, the distance they must cross has fundamentally measurably decreased. Length contraction and time dilation are two sides of the same cosmic coin. They are spacetime's conspiracy to uphold the law. The traveler experiences less time, but also has less distance to cover. The ratio between them, their speed, is measured consistently, and the speed of a photon from their headlight as it crosses this shrunken space in their slowed down time remains precisely immutably the speed of light. These effects are already bewildering a vision of a fluid, malleable reality. They hint at the power and strangeness locked within velocity. But there is a third consequence, a final insurmountable barrier that emerges from Einstein's logic, the one that builds the ultimate wall between us and the speed of light. It comes from the most famous equation ever written, E equals mc squared. We often think of this as the recipe for a bomb, the key to unlocking the power hidden inside the atom. But its true meaning is far deeper, far more fundamental. It is a statement of cosmic equivalence. It says that energy and mass are not separate things. They are two different faces of the same underlying substance. Mass is a form of concentrated frozen energy, and energy under the right conditions has mass. This is the key that locks the door to light speed. Think of your starship again. To make it go faster, you need to give it energy. You fire its engines, you push it, you accelerate it. But as you pump more and more kinetic energy into the ship, something from a nightmare begins to happen. The ship gets heavier. A portion of the energy you are using to accelerate it is not contributing to its speed. It is being converted directly into mass. At everyday speeds, this effect is infinitesimally small, utterly undetectable. You don't get heavier by running for a bus. But as you approach the speed of light, the effect becomes catastrophic. The closer you get, the more dramatic the mass increase becomes. At 87% of light speed, your ship's mass has doubled. It now takes twice the energy to achieve the same amount of acceleration. At 99.5% of light speed, its mass is 10 times greater. Push it to 99.9% and its mass multiplies by over 20. It is a curve of diminishing returns that spirals into infinity. Each new burst of acceleration adds more mass than it does speed. You are trying to push a boulder up a hill, and with every push, the boulder grows larger and heavier. The final few meters per second of your journey require more energy than the entire trip that came before. And so we arrive at the Great Wall, the absolute cosmic speed limit. To reach the speed of light 100%, the equation tells us that your ship's mass would become infinite. To accelerate an infinite mass, you would need an infinite amount of energy. There is not enough energy in the entire observable universe to push a single grain of sand to the speed of light. It simply cannot be done. This is not a technological limitation. It is not a matter of building better engines or finding a more potent fuel. It is a fundamental law woven into the fabric of space-time. The universe itself forbids it. Light can travel at light speed only because it has no rest mass to begin with. Photons are pure energy. They are born at that speed and die at that speed. They never accelerate and they never slow down. They simply are. For them, time does not pass. A photon that leaves a distant galaxy and travels for 10 billion years experiences its entire journey from emission to absorption in a single instant. It traverses the cosmos without a single tick of its own internal clock. But for us, for anything made of matter, for atoms and people and starships, that velocity is a forbidden kingdom. It is a horizon we can approach, but never ever reach. Special relativity has erected a fortress around the speed of light, a fortress with 3 towering walls. The wall of time, which slows to a crawl, stretching a journey into eternity. The wall of space, which warps and distorts our path. And the final highest wall, the wall of mass, which rises to infinity, demanding an impossible price for the final step. The laws of physics, as we understand them today, are not suggestions. They are the rigid framework of our reality, and they have posted a sign at the edge of the cosmos, a clear, unambiguous declaration that reads, "No trespassing, speed limit strictly enforced." This is the universe we inhabit, governed, constrained, and defined by this limit. Our greatest dreams of interstellar travel seem dashed against this cosmic law. The universe has built an impenetrable prison, a beautiful, wondrous, but ultimately inescapable cage. And so we stand before this wall, armed with this knowledge. The physics is clear, the mathematics is undeniable. But humanity has always been a species of dreamers, a species that looks at walls and wonders, what if? What if there was a loophole, a hidden passage, a way to break the law, or perhaps to find a higher law that allows it? What if, against all logic and reason, we could travel at light speed today? The universe has laws, immutable principles written into the vacuum of space itself. And the most unyielding of these laws, the one that governs all motion, is the absolute inviolable speed of light. It is a wall, a cosmic speed limit we can approach but never reach, a fundamental truth that seems to lock humanity within its own solar system. But what if the law itself has a loophole? What if the wall was never meant to be broken but instead to be bypassed? In the quiet halls of theoretical physics far from the engine rooms of NASA, a few brilliant minds have dared to ask this question. They have sketched out blueprints for impossibilities. They have found whispers in Einstein's own equations that suggest a way around, not by brute force, not by building a faster engine, but by rewriting the rules of the journey itself. By grabbing the very fabric of space-time and bending it to our will. This is not a story of conventional travel. This is the story of how we might cheat the cosmos. It began as many revolutionary ideas do not with a grand experiment, but with a thought experiment, a flash of profound insight. In 1994, a Mexican physicist named Miguel Alcubierre was watching science fiction. He was intrigued by the concept of a warp drive, a staple of interstellar fantasy that allowed starships to leap between galaxies. But Alcubierre saw more than just fantasy. He saw a genuine question rooted in the physics of general relativity. Could you, he wondered, to move a region of space itself faster than light? Einstein's theory is clear. Nothing within space-time can exceed light speed. Your ship, your body, any piece of matter is bound by this cosmic decree. But the theory places no such limit on the expansion or contraction of space-time itself. The universe proved this in its very first moments. During the inflationary epoch, the cosmos ballooned in size, expanding at a rate that far outstripped the speed of light. Space itself was the runner, and it broke the ultimate record. This was Alcubierre's revelation. This was the loophole. If you can't outrun the light, then make the racetrack move for you. Imagine you are standing on a rug. The far end of the room is your destination, impossibly distant. You cannot run fast enough to reach it in your lifetime. So instead of running, you pull the rug towards you. The destination comes to you while you yourself have barely moved. This is the sublime, audacious concept behind the Alcubierre drive. It does not propel a ship through space. It moves a bubble of space with the ship nestled safely inside. The mathematics he developed described something astonishing. A vessel would create a wave in the geometry of the universe. In front of the ship, space-time would be powerfully compressed, bunching up the distance to the destination like an accordion. Behind the ship, space-time would be dramatically expanded, pushing the starting point further and further away. The ship itself rests inside this warp bubble in a pocket of flat, undisturbed space-time. For the passengers inside, it would be the smoothest ride imaginable. There would be no crushing G-forces, no sense of acceleration at all. You could sip a cup of coffee completely unaware that you were crossing the galaxy. You are not moving. You are in a very real sense stationary. You are a surfer motionless on your board, carried forward on a colossal silent wave of space-time itself. Outside your window, the universe would warp and distort in breathtaking ways. Stars would not streak by as they do in fiction. Instead, the view ahead would become intensely blue-shifted light waves from your destination compressed into high-energy frequencies. The view behind would be terrifyingly red-shifted, stretched into the long fading waves of radio and microwave. You are not flying towards Alpha Centauri. You are pulling Alpha Centauri towards you while pushing Earth away. The distance you could cover would be in theory limitless. A journey of 10 light-years could be completed in a week, 1,000 light-years in a year. A trip to the Andromeda Galaxy, 2.5 million light-years away, could become a generational voyage, not a journey of millions of years. It is a vision of travel so profound it borders on the divine. It is humanity escaping the cradle of Earth, not by building a faster horse, but by becoming masters of the cosmic terrain. It is without a doubt the most elegant solution to interstellar travel ever conceived. And it is almost certainly impossible. The universe, it seems, does not give up its secrets so easily. For every beautiful equation, there is a cruel and unyielding reality. The Alcubierre Drive, for all its mathematical grace, comes with a price tag so impossibly high it breaks the bank of physics. The first problem is one of raw power. To warp space-time on this scale, to compress and expand the universe at will, requires a simply staggering amount of energy. Early calculations suggested you would need the total mass energy of the entire observable universe. More refined models brought the number down, but down is a relative term in cosmology. The newer estimates require the mass energy equivalent of the planet Jupiter, not the energy Jupiter produces. The energy you would get if you annihilated the entire planet, every atom of gas, every molecule of metallic hydrogen, and converted it into pure energy with 100% efficiency. We struggle to harness the power of a single star from a distance of 93 million miles. The idea of harnessing, containing, and manipulating the energy of a gas giant is a technological feat reserved for a civilization of gods. But even if we could summon such power, we face a far stranger and more fundamental obstacle. The Alcubierre Drive cannot be powered by any form of energy we know. It requires something else, something theoretical, something that may not even exist. It requires exotic matter. To understand why, we must look at how gravity works. Normal matter and energy, the stuff that makes up you, me, the Earth, and the stars, has a positive energy density. According to Einstein, this positive energy curves space-time in a specific way. It creates an indentation, a gravity well. It pulls things together. But to create the Alcubierre warp bubble, you need to do the opposite. To expand space-time behind the ship, you must push it apart. You need anti-gravity. This requires a substance with a negative energy density, a phantom material that would, in theory, have negative mass. If you were to hold a chunk of it in your hand and let go, it wouldn't fall, it would fly upwards. If you pushed it, it would accelerate towards you. This is exotic matter, a cosmic unicorn, a substance that violates what we know about the physical world. Physicists have never observed it. We have never created it. We have only found faint, fleeting hints of its properties in the quantum realm. In a phenomenon known as the Casimir effect, two uncharged conductive plates placed incredibly close together in a vacuum will feel a tiny, inexplicable force pushing them together. One interpretation is that the space between the plates has a lower energy density than the vacuum outside of it, a kind of negative energy. But this is a microscopic ephemeral effect, a quantum ghost. To weaponize this faint quantum whisper into a stable macroscopic substance capable of propelling a starship is a leap beyond imagination. It may be that the universe simply forbids such a material from existing on any meaningful scale for the very good reason that it would allow for all manner of causal paradoxes. It is the ultimate barrier. The engine requires a fuel that may be pure fiction. And yet, let us dream for a moment. Let us imagine a distant future where we have solved these colossal problems. We have harnessed the energy of 1,000 suns. We have manufactured stable, controllable, exotic matter. Our first warp-capable vessel, the Wanderer, sits ready on a launch pad in lunar orbit. Its destination, the Earth-like planet orbiting Proxima Centauri 4.2 light-years away. Even in this perfect future, the crew faces dangers of a new and terrible kind. The laws of physics, even when bent, have a way of fighting back. The first, most disorienting problem is control. The inside of a warp bubble is a causally disconnected island of spacetime. Nothing can get in, nothing can get out. This means no signals, no messages, and no light from the outside universe can reach the ship. The crew is flying completely blind. They cannot see their destination. They cannot steer the bubble. They cannot even send a signal to turn the drive off. The entire journey from start to finish must be pre-programmed with impossible precision. Any unforeseen object in their path, a rogue asteroid or even a cloud of dust, would be undetectable. The journey must be plotted across a map of space-time that is years out of date, as the light from the destination takes years to reach us. It is the equivalent of trying to drive a car at 1,000,000 miles per hour at night with the windshield blacked out using a paper map from a decade ago. The margin for error is zero, but a far more horrifying danger awaits not the crew but their destination. The front of the warp bubble, the region of compressed space-time, acts like a cosmic snowplow. As it tears through the interstellar medium, it gathers up any particles it encounters: hydrogen atoms, dust grains, stray photons. Because the bubble is moving faster than light, these particles cannot get out of the way. They become trapped on the leading edge of the wave. And as the journey progresses, more and more particles accumulate, energized to unbelievable levels by their relativistic encounter with the bubble. They form a bow shock of incandescent high-energy radiation, a shell of destructive potential that grows with every light-year traveled. The crew inside remains blissfully unaware, protected within their tranquil pocket of space. But when the Wanderer finally arrives at Proxima Centauri and decelerates when the warp drive is finally shut down, that accumulated shell of radiation is unleashed. It would be a cataclysm, a gamma-ray burst of unimaginable intensity, blasting forward at the speed of light. It would vaporize any welcoming committee, sterilize the surface of the target planet, and potentially destroy the entire star system. In our heroic attempt to reach a new world, we would arrive as unintentional agents of cosmic annihilation. Our first handshake with an alien world would be a blast of lethal radiation. The Alcubierre Drive, the great hope for interstellar travel, might also be the perfect and most terrifying weapon ever conceived. It's a chilling thought that the physics of faster-than-light travel might be intrinsically unavoidably destructive. So if we cannot surf the cosmic ocean, what other options remain? Perhaps we do not need to travel the distance at all. Perhaps we can simply bypass it. If bending space presents too many paradoxes, what if we were to puncture it, to fold it deep within the same equations of general relativity that inspired Alcubierre? Lies an even older, even more mind-bending concept, a shortcut through the universe, a cosmic doorway. Known to science as an Einstein-Rosen bridge, we know it by a more evocative name, the wormhole. The idea is as simple as it is profound. Imagine space-time is a vast sheet of paper. To get from point A on one side to point B on the other, you must trace a long, slow path across the surface. But what if you could fold the paper, bringing point A and point B right next to each other? then all you would need to do is poke a hole through the paper, creating a tunnel, a throat that connects the two distant points. You would not have traveled across the space, but through it. A journey of 1,000,000 light years could become a journey of a few meters. This is not mere speculation. It is a valid mathematical solution to Einstein's equations. The universe, according to our best theory of gravity, could be riddled with these topological tunnels, these secret passages woven into the fabric of reality. Finding one or creating one would be the greatest discovery in human history. It would change everything. Space travel would no longer be a matter of propulsion and velocity. It would be a matter of cartography, of mapping these hidden connections, these stellar subways. Journeys would not take centuries. They would take moments. One could step through a gateway in our solar system and emerge seconds later in the swirling nebulae of the Orion Arm, or gaze upon the supermassive black hole at the center of our galaxy. The universe would shrink from an endless lonely void into a connected, accessible neighborhood. Humanity would become a truly galactic civilization overnight. To travel through a wormhole would be the ultimate trip. Approaching its mouth, space-time would become profoundly curved. Light from the other side would be distorted, gravitationally lensed, creating a shimmering spherical window into a distant region of the cosmos. It would look like a crystal ball reflecting a far-off star field. Plunging through the throat would be a journey through a higher dimension. The familiar 3 dimensions of space would twist and warp around you. It would be a disorienting, perhaps terrifying, but ultimately brief passage. And then you would emerge, out of a second shimmering sphere, into a new solar system, a new galaxy, billions of light years from where you began. The starlight entering your eyes would have started its journey long before humanity ever existed. You have not broken the speed of light. You have simply taken a shortcut that light itself could not. It is a breathtaking vision of our cosmic future. And like all beautiful visions of faster-than-light travel, it is plagued by devastating fundamental problems. The first issue with the classic Einstein-Rosen bridge is its catastrophic instability. The mathematics that predicts their existence also predicts their behavior, and that behavior is violent self-destruction. A wormhole is not a static tunnel, it is a dynamic, evolving piece of space-time geometry. The moment it forms its own immense gravity, the intense curvature of its throat causes it to collapse back in on itself. This collapse is not slow, it happens faster than the speed of light. This means that nothing, not even a single photon, has time to pass through it. It is a doorway that slams shut before you can even take a step through it. Any astronaut attempting to traverse such a wormhole would be caught in the collapsing throat and crushed into a singularity, a dead end, another beautiful idea seemingly killed by the harsh realities of physics. But what if there was a way to force the door open? What if we could prop up the walls of the tunnel and keep it from collapsing? Physicists like Kip Thorne explored this very question, and they found a solution, a way to create a traversable wormhole. The solution, however, should sound unnervingly familiar. To fight the crushing gravity of the wormhole's throat, to push space-time outward and stabilize the tunnel, you need a substance with repulsive, anti-gravitational properties. You need exotic matter. It is the same phantom substance required for the Alcubierre drive, the same cosmic unicorn, the same material with negative energy density. It seems the universe has a preferred ingredient for its most exotic recipes. To build any machine that allows for faster-than-light travel, whether by bending space or folding it, we must first master a form of matter that may not even be real. It is the great wall standing between us and the stars. Exotic matter is the key that unlocks these cosmic gateways, and it is a key we do not have and may never find. It suggests a deep underlying principle at work. Perhaps the universe is structured in such a way as to specifically prevent these kinds of shenanigans, to protect the integrity of its own laws. Because with traversable wormholes comes an even greater paradox, one that threatens not just physics but logic itself, the paradox of time travel. A wormhole connects 2 points in space, but it also connects 2 points in time. By exploiting the strange effects of time dilation from special relativity, a wormhole could be easily converted into a time machine. The process is deceptively simple. Imagine we create a stable wormhole with one mouth near Earth and the other in orbit around a distant star. We take the distant mouth on a journey. We accelerate it to near the speed of light, fly it around for a while, and bring it back. For the crew on that ship, time would have passed very slowly. For everyone on Earth, decades, perhaps centuries would have gone by. The two mouths of the wormhole are now desynchronized in time. The mouth near Earth is in the year 2300. The mouth we took on a journey is in the year 2100. Now if you step into the mouth in 2300, you will emerge from the other mouth in 2100. You have just traveled 200 years into your own past. You have created a pathway that violates causality. You could go back and prevent your own parents from meeting. You could give the Roman Empire the secrets of nuclear fusion. You could create a logical contradiction so profound that the history of the universe would unravel. This is the infamous grandfather paradox, and it is a problem so severe that many physicists believe the universe must have a law to prevent it, a principle called the chronology protection conjecture. This conjecture suggests that the laws of physics are ingeniously conspired to prevent the formation of these causal loops. Perhaps the very act of trying to turn a wormhole into a time machine generates a feedback loop of energy that destroys it, a cosmic security system that shuts down any attempt to rewrite its own history. The universe, it seems, fiercely protects its past. So where does this leave us? With two magnificent, elegant, and deeply flawed blueprints for the stars, the warp drive and the wormhole, two sides of the same incredible coin, both born from Einstein's greatest theory, both promising to unlock the galaxy, and both demanding a price we cannot pay, a price measured in the energy of entire worlds, a price demanding a form of matter that exists only on blackboards, and a price that may challenge the very flow of time itself. Are these ideas merely beautiful flights of mathematical fancy, or are they faint glimpses of a physics so advanced it seems like magic to us? A technology that might one day be harnessed by a civilization millions of years ahead of our own. We stand before the wall of light, a seemingly impassable barrier, and we have found scribbled in its foundation these tantalizing clues, these theoretical cracks in its surface. They remain far beyond our grasp, perhaps forever, but they have changed the way we see the cosmos. They have shown us that the universe is not just stranger than we imagine, it may be stranger than we can imagine, and they force us to ask a final, profound question. Are we staring at an absolute cosmic law, or are we simply children looking at a door whose key is yet to be forged? Imagine the moment the world holds its breath. It is not an act of war, not a natural disaster. It is an announcement broadcast on every screen in every language, a quiet statement of fact that rearranges reality itself. The switch has been flipped. Here on Earth, in a shielded facility hidden from the world, a vessel built by human hands has just folded space. The Alcubierre Drive, a myth, a piece of science fiction mathematics. A dream of physicists is no longer a dream. It is a functional, stable, and tested piece of technology. It exists today. Right now, in that singular instant, the universe you thought you knew vanishes forever. The great dark ocean between the stars, a chasm of distance, that took light itself years, centuries, millennia to cross. That impenetrable barrier, the ultimate prison wall for our species, has just been torn down. The speed of light is no longer the law. It is a suggestion, a quaint, local ordinance that we can now politely ignore. Think about what this truly means. All of human history has been a story told on a single tiny island, an island of rock and water, adrift in an endless, unreachable sea. We have gazed at the other islands, the distant points of light. We named them, studied their faint whispers of chemistry. But we knew in our bones that we could never visit. That knowledge shaped everything about us. Our philosophies, our religions, our sense of self. We were a species defined by our magnificent solitude. Until this moment. The hourglass of cosmic distance with its slow trickle of light years has just been shattered into a billion pieces. There is no longer a journey, there is only arrival. Consider Mars, the red planet, the object of our obsession. A grueling 6 to 9 month voyage through brutal radiation, a one-way trip fraught with 1,000 points of failure. Now the journey is a matter of minutes. You could board a ship in a terrestrial spaceport after breakfast. You would feel a subtle shift, a strange, indescribable lurch, not of acceleration but of space-time itself being rewoven around you. And before your coffee has even had a chance to cool, you would look out the viewport, and you would not see the receding blue marble of Earth. You would see the ochre alien canyons of Valles Marineris, stretching across a world that was a moment ago 40 million miles away. Olympus Mons would not be a telescopic smudge. It would be a titan of a mountain, its caldera filling your entire view. The first human missions would not be for survival, they would be for settlement. The logistics of building a city on Mars, once a century-long problem, becomes a weekend delivery schedule. Water ice from the poles, building materials, atmospheric processes, all of it can be ferried from Earth in less time than a transatlantic flight. Mars is no longer a frontier, it is a suburb. And that is just the first, most timid step into our new reality. Why stop at our next-door neighbor? The true jewels of our solar system have always been tantalizingly out of reach, locked behind years of travel time. Now they are all on the table. Europa, the ice-crusted moon of Jupiter, hiding a global ocean that may contain more water than all of Earth's seas, an ocean that might hold life. For decades we have dreamed of sending a submarine to probe its depths, a mission that would take the better part of a decade just to arrive. Today, a team of astrobiologists could commute there. They could land on the chaotic, fractured ice plains in the afternoon, deploy a drill, and by evening be streaming live video. From the crushing, eternal darkness beneath Europa's frozen shell, we could watch together as the floodlights of a submersible cut through a realm unseen for 4 billion years, searching for the first definitive proof that we are not alone. And if not Europa, then perhaps Titan, Saturn's giant moon, a world of nitrogen smog with mountains of water, ice, and vast, placid seas of liquid methane and ethane. Imagine standing on its shore under a perpetual orange twilight. The colossal rings of Saturn, a permanent, breathtaking arc in the sky, watching as liquid methane rain falls from the hazy clouds. This is not a computer simulation. This is a destination, a place you could actually go. The solar system, once an incomprehensible void of distances, has become our backyard, a cosmic playground. The asteroid belt, a treasure trove of metals and minerals, is no longer a distant dream of robotic mining. It is an open quarry. The resources available to humanity would multiply by a factor of trillions. The very concept of scarcity, the engine of all our conflicts, would be fundamentally rewritten. We would have access to more energy, more raw materials than our civilization has used in its entire existence. The economic and political structures of Earth would be obsolete overnight. Nations defined by borders on a single planet become an absurd anachronism. When a corporation can establish a helium-3 extraction plant on Uranus, what is a border, what is a country? We would be forced to redefine ourselves not as Americans or Chinese or Nigerians, but as Solarians, citizens of a star system. This is the exhilarating part of the equation, the sudden explosive expansion of the human canvas. We would be released from our planetary cradle, free to explore, to build, to settle, to become something new. A multi-world species finally secure from the cosmic accidents that could extinguish all life on a single fragile planet. But this is only the beginning. The local neighborhood, the truly profound, the truly terrifying change is what lies beyond Alpha Centauri, our nearest stellar neighbor, 4.2 light-years away. A journey of 75,000 years with our fastest current probes, an impossible distance, an uncrossable gulf until today. With an Alcubierre drive, the subjective travel time would be a matter of weeks, maybe days, depending on the engine's power. A ship could depart Earth orbit, leaving our familiar sun behind, watching it shrink to become just another star among millions. The crew would exist inside their bubble of flat spacetime, while the universe itself is warped around them. And then, after a quiet, uneventful voyage, a new star would begin to dominate the forward view. Not our gentle yellow sun, but a fierce orange-hued star. And next to it, a smaller, angrier red dwarf, Proxima Centauri. Circling that red dwarf is a planet, Proxima Centauri b, the first alien world, the first exoplanet that humanity could touch. Imagine the final approach. Imagine the first images being sent back to Earth. Not a blurry dot of light, not an artist's impression, but high-resolution video of an alien world's continents, oceans, and clouds. What would we see? A tidally locked world, one side forever, scorched one forever frozen. A planet bathed in the crimson light of its parent star. What color would its plants be if they exist? Black to absorb the dim light. What would its atmosphere feel like? What would it smell like? The moment the first human explorer steps out onto that world, the entire context of our existence shifts on its axis. That single footprint in alien soil would be a bigger leap than every discovery, every invention, every work of art in our history combined, because it would prove that the worlds of our imagination are real. The catalogue of thousands of confirmed exoplanets we have so painstakingly built, the Keplers, the Trappists, the hot Jupiters and super-Earths, that catalogue is no longer an academic exercise. It is a travel brochure, a list of destinations. Humanity would stand on the shore of the galactic ocean holding the keys to every harbor. We could visit planets where the skies are green and the suns are blue. We could witness worlds orbiting pulsars bathed in eerie rhythmic light. We could see planets with 2 or 3 suns casting multiple shadows. We could explore rogue planets cast out from their systems, wandering alone in the interstellar darkness, worlds of eternal night. The age of discovery we once read about in history books, the era of Magellan and Columbus, would seem like children playing in a sandbox by comparison. We would be the cartographers of the galaxy. The scientific and philosophical revelations would be overwhelming. We could find answers to the deepest questions we have ever asked. How common is life? Is it everywhere, or is it a precious fluke? Are the laws of physics truly universal, or do they vary? We would no longer be guessing. We could go and check. Our understanding of the cosmos would explode. And this leads to the most profound and most unsettling consequence of all. For our entire existence we have shouted into a silent cosmos, the great silence, the Fermi paradox. If the universe is so vast, why has no one else called back? We have always assumed the silence was due to the immense distances. A conversation between stars would take centuries. but we just solved that problem. The Alcubierre Drive is a bridge across the void. And if we, a fledgling chaotic species on a single planet, could figure out how to build this bridge in a mere few centuries of science, what does that say about a civilization that is 1,000 years older than us, or 1,000,000 or 1,000,000,000? The silence is no longer a comfort, it is a threat. Because if we can cross the void, it means they can too. Suddenly, we are no longer alone in an empty house. We have just unlocked the front door and realized the house is in the middle of a bustling ancient city, and we have no idea who our neighbors are. The question, "Are we alone?" transforms into a terrifyingly practical one. Are we safe? Every new system we visit is a roll of the dice. Is it empty, or is it occupied territory? Do we stumble into a nature preserve, a holy site, or the heart of an empire that does not welcome visitors? First contact ceases to be a philosophical concept. It becomes an imminent statistical probability, an event that could happen at any moment without warning, and we would be the newcomers, the children, stepping onto a galactic stage where the rules were written eons before we were born. The existence of this drive forces a cosmic humility upon us. It ends the innocent arrogance of being the sole intelligence we know. All of our earthly concerns, our wars, our politics, our beliefs, would be rendered instantly terrifyingly trivial. Humanity would have to unify not out of idealism but out of necessity. The species would be our only meaningful tribe, our single planet, the cradle we must protect. Because for the first time, we would have something to compare ourselves to. Our place in the universe would be radically redefined. We are not the pinnacle of creation. We might not even be particularly interesting. We might be one of billions of intelligent species, a footnote in a galactic history that is still being written. This single invention changes the definition of what it is to be human. Our potential is no longer bound by a single star system. Our future is no longer tied to the fate of a single world. We could spread, diversify, and evolve in ways we cannot even imagine. Humans born and raised on a low-gravity world might become taller, more slender. Those on a high-gravity planet, more compact and powerful. Our culture would splinter and merge with unimaginable new influences. 1,000 new branches of humanity could bloom among the stars. The lifespan of our species would be extended from millions of years to potentially billions, outliving our own sun. We would become, for all intents and purposes, immortal. But the change is also personal. It is for you. Right now, you are rooted to this planet. Your life, your experiences are constrained by geography and time. With this technology, that reality dissolves. You could visit the rings of Saturn as a tourist. You could study alien biology on a world 100 light-years away. You could join a construction crew building a city in the clouds of Venus. You could choose to leave Earth and never return, seeking a new life, a new beginning on a new world of your choosing. The very concept of home would become fluid. Your identity would be untethered from a place of origin and would instead be defined by your journey. The switch has been flipped. The world of yesterday with its familiar limits and its comfortable solitude is gone. A new era has dawned not in 1,000 years but today. An age of infinite possibility and unimaginable peril. We have broken the chains of gravity and the tyranny of light. We have opened Pandora's box, and inside is the entire universe. The human story is no longer about one world. It is about to become a story written among the stars, and we have no idea how it will end. The great adventure has just begun. The moment we mastered light, the universe shrank to our doorstep. The starlight that once took centuries to reach our eyes could now be overtaken in a single breathtaking journey. The dream was realized. The galaxy was finally ours to explore, and in that moment of ultimate triumph, the foundations of reality began to fracture. we discovered that in our haste to break the cosmic speed limit, we had broken a far more fundamental law, a law that governs not just space, but the very flow of existence, the inviolable sequence of cause and effect. You see, our universe is built on a simple, ruthless principle. Yesterday gives birth to today. Today leads inexorably to tomorrow. An action is taken and a consequence follows, always in that order. It is the bedrock of logic, of sanity, of all that we understand. But faster than light travel tears this tapestry of time apart. Einstein showed us that time itself is not a universal constant. It is a fluid, a current that flows at different rates for different observers. The faster you move, the slower your personal clock ticks relative to a stationary one. This isn't a theory. It's a measured, observable fact of our cosmos. And at speeds below light, it poses no existential threat. But once you cross that threshold, you don't just bend time. You give yourself the power to snap it in two. Imagine a simple scenario. A human colony on Proxima Centauri b, 4.2 light-years from Earth. With our new technology, a ship can make the trip in a matter of weeks. A communications laser traveling at light speed takes over 4 years. A catastrophe occurs on the colony. A reactor breach. A rescue ship is dispatched from Earth, arriving weeks later. But a desperate leader on the colony also sends a warning message, a message encoded on a faster-than-light signal. From the perspective of those on Earth, a horrifying sequence unfolds. The rescue mission is launched into the silent darkness. Weeks pass. Then, a day before the ship is scheduled to arrive, the faster-than-light message blinks into existence in mission control. It's a plea for help from the future. A detailed report of the disaster that for the rescue crew has not yet happened. A ghost crying out from a tomb that has not yet been sealed. The message has arrived before its cause. The effect has preceded the action. This is more than a curiosity. It is a logical monstrosity. The universe should not permit such a thing. It's like hearing the thunderclap before the lightning has even formed. It's finding a footprint on a path that has not yet been trod. But it gets profoundly stranger and infinitely more perilous. What if you could use this technology not just to receive information, but to send it into your own past, to alter the chain of events? You now possess a device that can transmit a message 1 hour into the past. You sit down to watch the global stock market. You see a catastrophic, unexpected crash that wipes out fortunes. So you calmly take out your device and send the final ticker results back in time to yourself 1 hour ago. Your past self receives this impossible data, this list of winners and losers from a future that is yet to be written. You sell every stock that is about to plummet, buy every one that will soar. You become titanically wealthy thanks to information that appeared from nowhere. But where did that information truly originate? You only knew which stocks to pick because your future self told you, and your future self only knew because they experienced the unaltered timeline. But by acting on the information, you erased that original timeline. The crash you witnessed never happens in your new history. So the very event that prompted you to send the message never occurred. The information has no point of creation. It is a ghost, a bootstrap paradox, an idea with no author, a book with no writer, existing in a closed loop of time. Reality itself becomes a hall of mirrors with no clear origin. And from this dizzying conundrum emerges an even darker potential. The power not just to observe the past, but to murder it. The infamous spectre known as the grandfather paradox. You build a machine that can send a single bullet back in time. You aim it at the place where your own grandfather stood as a young man long before he met your grandmother. You fire. In the past he dies. He never has children. Your parent is never born. And so you are never born. But if you were never born, who fired the shot? The universe is now locked in an impossible contradiction. A statement that is both true and false at the same time. You exist and you do not exist. The shot was fired and it was not. This isn't just a puzzle for philosophers. It is a cosmic constitutional crisis. If the past can be changed, then history is not a record. It is a flickering, unstable manuscript, vulnerable to the edits of any future tyrant. Every triumph, every sacrifice, every moment of human history could be erased in an instant by a single message sent back through time. The very ground beneath our feet, the story of who we are, crumbles to dust. Perhaps the universe has a defense mechanism, a self-correction protocol. Some physicists theorize that any action that would create a paradox is simply forbidden. The gun would jam, your aim would falter, a meteor would strike the machine. The cosmos would conspire in endlessly creative ways to preserve its own sanity. History, this theory suggests, is robust. It protects itself. Or maybe the resolution is even more unsettling. Perhaps when you send that message, you don't change your own past. You create a new one, a divergent reality, a parallel universe. In that new timeline, your grandfather is gone. You are never born. But you, the architect of this change, remain in your original timeline, now haunted by the knowledge that you have orphaned an entire reality. We would become creators of fractured, broken universes. With every paradoxical act, we would splinter off another timeline, leaving behind a wake of cosmic debris of alternate histories where our actions have wrought untold, unknowable consequences. Our quest for the stars would make us careless gods, playing dice with realities we could never hope to comprehend. But even if we could somehow navigate these treacherous currents of time, an even more profound labyrinth awaits us. Not a maze of physics, but one of morality. A dilemma that begins the moment our first starship arrives at a world that is not our own. Picture it. A planet bathed in the light of a star unlike our sun. Continents of iridescent flora that pulse with a soft internal light. Oceans of ammonia churning beneath skies of methane haze. And in those oceans life. Not intelligent life, not yet, but life nonetheless. A unique biochemistry, a billion-year journey of evolution that has produced creatures of breathtaking, terrifying beauty. A pristine genesis untouched, unobserved since its dawn. Our ship arrives a sterile, metallic intruder in this perfect garden. And with us we bring Earth. Not the soil or the trees, but our invisible passengers. The trillions of microbes that coat our bodies, our ships, our equipment. Bacteria, viruses, fungi, hardened survivors from our own world's brutal evolutionary arena. To this new world, our microscopic colonists could be a plague of biblical proportions. A single Earth bacterium finding a defenseless ecosystem with no immunities could replicate uncontrollably, consuming the native biochemistry. It could trigger a biological apocalypse, an extinction event so complete it would erase an entire biosphere before we had even finished cataloguing it. We could, in our ignorance and clumsiness, become the great filter. The reason the skies are so silent, we would arrive as explorers and leave as destroyers. The history of exploration on our own planet taught us this brutal lesson. Centuries of contact between cultures led to disease, subjugation, and erasure. We promised civilization and often delivered ruin. Now we risk repeating those same sins on a cosmic scale, armed with a technology that makes us feel invincible. Our arrival could be a death sentence delivered from the stars. And what if we find something more? Not just alien microbes, but alien minds. A species that has built cities, composed music, pondered its own stars. What is our duty then? What is our right? Do we announce ourselves? A thunderous arrival from the heavens, shattering their conception of the universe and their place within it forever. How could their cultures, their religions, their social structures possibly survive such a shock? We would become their new gods or their new devils. the temptation to interfere would be immense, to share our technology to cure their diseases, to uplift them. But who are we to decide what constitutes a better existence? Our solutions for our problems may be poison to theirs. Our concepts of individuality, of progress, of ambition might be utterly alien and destructive to a collective consciousness or a species that lives in harmony with its world in ways we've long forgotten. We would face an agonizing choice: to remain silent, to quarantine an entire solar system, observing from afar like zookeepers, denying them the truth of the cosmos, or to make contact and in doing so risk becoming the architects of their cultural demise, an unstoppable force of change that they never asked for. The Prime Directive is not just a fiction, it is the central ethical crisis of an interstellar age, a burden of knowledge that may be too great for any species to bear. Perhaps the greatest danger, however, is not what we might do to the galaxy, but what the galaxy in its profound strangeness might do to us. Our minds have evolved over millions of years to understand this world, to recognize faces, to navigate landscapes, to communicate with our own kind. Our entire consciousness is shaped by the familiar physics and biology of Earth. Now imagine encountering an intelligence that shatters every one of those foundations. Not a bipedal creature with large eyes and a familiar emotional range, but something utterly fundamentally other, a sentient crystal the size of a mountain that communicates through modulating gravitational fields. A collective intelligence residing in a planet-wide ocean with no concept of the individual, a being made of pure energy, living in the corona of a star. How does the human psyche process that? We search for patterns, for familiarity, for something we can relate to. What happens when we find nothing, when we are confronted with a form of life so alien that our categories of thought, of life and death, of individual and society, of love and hate, are rendered utterly meaningless? It is a confrontation with the absolute unknown, a psychological shock so profound it could fracture the human mind. Our cherished sense of self, our place as the universe's lone thinkers, would be annihilated in an instant. We might not be at the top of the food chain, or even on the same food chain at all. We might be to such a being what an ant is to us, or less, entirely irrelevant. But there is another possibility, one that may be even more terrifying. We achieve light speed. We pour out into the galaxy with breathless anticipation. We visit 1,000 suns, 100,000, 1,000,000. We scan every habitable world, every promising moon, every asteroid belt, and we find nothing, absolutely nothing. No signals, no artifacts, no ancient ruins, no alien fossils, just planets that are either barren rock or teeming with simple, non-sentient life. Worlds of endless bacterial slime, of mindless crawling things, of silent alien forests. The cosmos is a magnificent, sprawling and utterly empty house. The great silence we once pondered from afar becomes a suffocating experienced reality. We are confronted with the crushing, undeniable truth of our own solitude. We are it, the only ones. A singular freak accident of chemistry and circumstance on a tiny, fragile world. A brief spark of consciousness in an eternity of mindless matter. What would that knowledge do to the human spirit? The hope that drove us to the stars would curdle into a profound species-wide despair. The search for connection would be replaced by the certainty of cosmic isolation. Religions would crumble. Philosophies would be rendered moot. The universe, once seen as a place of infinite possibility, would become our magnificent, beautiful, and eternal prison. We would be the sole inheritors of a silent, meaningless kingdom. And while we grapple with these phantoms of the mind and spirit, a more immediate and brutal reality asserts itself with every single light year our starships cross. The simple, lethal physics of moving unimaginably fast. Space is not empty. It may look like a perfect void, but it is not. It is filled with a thin but persistent soup of interstellar dust and gas. Micrometeoroids, rogue specks of ice-stray hydrogen atoms. At normal speeds, these are utterly insignificant. But at 99.9% of the speed of light, the rules of kinetic energy transform the mundane into the cataclysmic. A single grain of sand no bigger than a millimeter across. Striking a ship at that velocity impacts with the energy of a tactical nuclear weapon. It would not simply dent the hull, it would create a rapidly expanding fireball of plasma, vaporizing a massive section of the ship in a microsecond. Shielding for such an event is almost impossible. How do you build a wall that can withstand a constant barrage of miniature atomic bombs? Every journey becomes a terrifying game of Russian roulette. Navigating the space between stars is not like sailing an open ocean. It's like sprinting blindfolded through a minefield. A stray pebble, a small chunk of ice no bigger than your fist would not just destroy the ship, it would annihilate it, releasing the energy of the most powerful weapon ever detonated on Earth. An instantaneous silent flash of light, and then nothing. This new lethal frontier inevitably creates a new kind of human, and with it a new and terrifying kind of division. The technology to travel the stars would be phenomenally expensive and complex. The shielding, the engines, the navigational computers, this would be the most difficult engineering humanity has ever attempted. Who would control it? Not everyone, not even most people. It would belong to the wealthiest nations, the most powerful corporations. A new elite would be born, the starfarers, those with the resources to build the ships and accept the risks. They would have access to the resources of entire solar systems, to worlds ripe for colonization, to mineral wealth beyond imagination. And what of those left behind on Earth? The billions who can only look up at the sky and watch the new aristocracy depart. Humanity would be cleaved in two, the earthbound and the starbound. A schism so fundamental it would make the divisions of nation, race and creed seem trivial by comparison. We would no longer be one species but two, defined by the most profound of questions: do you have access to the universe or not? From this ultimate inequality, the final darkest consequence of light speed is born. The technology that promised to unite us with the cosmos becomes the most perfect weapon we have ever conceived. Take one of our starships, or even just a large, dense asteroid. Accelerate it to a significant fraction of the speed of light. Point it at a planet. Point it at Earth. It is the ultimate kinetic bombardment. It cannot be stopped. It cannot be deflected. It travels so fast that it would be effectively invisible until the moment of impact. There would be no warning, no time to prepare, no hope of survival. The energy released would be unimaginable. Thousands, perhaps millions of times more powerful than the asteroid that wiped out the dinosaurs. It would crack the planet's crust, boil the oceans, and incinerate the atmosphere. A single targeted act of malice that could extinguish all life on a world. The power to hold entire planets, entire civilizations hostage. The ultimate deterrent. The final checkmate in the game of power. We reached for the stars hoping to find enlightenment and wonder. Instead, we found a way to weaponize the very fabric of spacetime. We sought to escape our old conflicts only to invent new ones of a terrifying scale. The dream of light speed has given us the power of gods, and with it, the all-too-human capacity to create a hell of our own making. The question is, no longer can we go. The question is, should we have ever left at all? The final barrier has fallen. The speed of light, that absolute cosmic speed limit, is broken. We have done it. We have built the impossible engine. The universe in its entirety now lies open before us. 1 trillion galaxies, a septillion stars, all within our reach. This was supposed to be the moment of our ascension, the final victory of intelligence over the indifferent void. But the truth we discovered out there in the silent dark, was not the one we were looking for. We set out to conquer distance, to make the cosmos small. Instead, we found that by breaking one law of physics, we had chained ourselves to others far more strange and far more unforgiving. The great paradox of faster-than-light travel is not a mechanical one. It is a crisis of reality itself, because when you travel faster than a beam of light, you are not just outrunning a photon, you are outrunning the very sequence of events. You are outrunning cause and effect. Imagine a simple act. You stand on Earth and send a message via FTL comms to a colony 100 light-years away. Your message, traveling at twice the speed of light, arrives in 50 years. The colonists receive it and immediately send a reply. Their response, also traveling at twice light speed, returns to you in another 50 years, a simple conversation, a round trip of 1 century. But this is where reality begins to fray at the edges. To an observer flying past Earth at a high relativistic speed, your perception of time is different. Because of the strange geometry of space-time from their perspective, the reply from that distant colony did not arrive after you sent your message. It arrived before. Think about what that truly means. You receive an answer to a question you have not yet asked. You see the effect before its cause has ever occurred. The script of the universe is no longer written in linear ink. It has become a chaotic, incomprehensible scrawl. Every FTL journey, every single jump into the superluminal is an act of temporal vandalism. You leave Earth in the year 2300 for a star 500 light-years away. The journey takes you mere weeks. But in the fabric of space-time, your arrival is not a simple dot on a map. It is a wound, a potential paradox. You could, in theory, arrive, turn around, and come back before you even left. You could watch your own ship sitting on its launch pad. This isn't a parlor trick. It's a fundamental breakdown of existence. History itself becomes a weapon. What if a rival faction travels to a star system where a crucial element for Earth's technology was forged in a supernova billions of years ago? And what if they arrive in that distant past and somehow prevent that star from ever collapsing? The element is never created. The technology on Earth is never invented. The FTL drive that sent them there never existed. Does the universe simply wink them out of existence? Or does it unravel all of history like a pulled thread? We call this the causality violation crisis. It is the chilling discovery that our newfound freedom is a key that unlocks the door to our own annihilation. The universe might have an immune system against such paradoxes, a way of enforcing the linear flow of time, but we have no idea what that enforcement looks like. Is it a quiet, subtle correction? Or is it a cataclysmic rupture in the fabric of space? Every time a ship engages its drive, we hold our breath. We roll the dice with all of creation, with every moment that has ever been. We thought we were explorers. It turns out we are temporal trespassers walking on eggshells through the museum of what was, is, and will be. This terror forces upon us the first great limitation, a prime directive, not for interacting with aliens, but for interacting with our own past. Strict, unbreakable protocols are established. No journey can create a pathway to a point in space-time prior to the departure of another vessel. We build a complex galaxy-spanning ledger of arrivals and departures, a choreography of motion designed to never let the dance of time fold back upon itself. We have the power to rewrite history, and so we must use all of our will to become its humble servants. The conquerors of light speed are now its most devoted prisoners. But even if we navigate the treacherous currents of causality, we face a second, more personal and perhaps more terrifying truth. A truth about what it means to be human when home is no longer a place, but a memory receding at impossible speeds. When you step aboard an FTL vessel, you say goodbye to your world. This is not the poetic farewell of ancient mariners. It is a literal, absolute severing. You travel for 6 months to a star in the Andromeda galaxy, 2.5 million light-years away. When you arrive, you are 6 months older, but the Earth you left is now 2.5 million years in the future. Every person you knew, every city you walked, every nation, every language, it is all gone, ground to dust by the relentless wheel of deep time. The planet you came from might not even exist anymore. The sun itself could be a cold, dead cinder. You are not a colonist. You are a refugee from a world that, from your new perspective, died geological ages ago. You are an artifact, a ghost. The signals from home, traveling at the sluggish pace of light, will continue to arrive for millions of years. You will receive news broadcasts from your childhood. You will see politicians debate issues that are now cosmic dust. You will watch the birth of your own children, long after they have lived, died, and their graves have been swallowed by the shifting continents. Your new world is haunted by the light of a dead past. This creates a profound and devastating psychological schism. We call it temporal dislocation. The human mind evolved to exist in a shared present. Our entire civilization is built on the idea of a universal now. FTL travel shatters that foundation. Every colony becomes an island, not just in space, but in time. A settlement on Proxima Centauri is 4 years out of sync with Earth. One in the Kepler 186 system is 500 years adrift. The one you stand on in Andromeda is millions of years disconnected. There is no longer a single human civilization. There are thousands of them scattered like seeds in the wind, each existing in its own temporal bubble. Each one an echo of a humanity that no longer exists. Communication becomes a form of archaeology. A message sent between two colonies in different galaxies is a time capsule, a voice from the impossibly distant past arriving in an incomprehensibly distant future. We had imagined a great galactic commons, a single conversation unfolding across the star lanes, a shared present binding our scattered children together. The reality is silence, an immense galactic silence punctuated by the faint whispers of ghosts arriving centuries, millennia, eons too late. Did we conquer the void, or did we just invent a new, more profound and permanent kind of loneliness? This leads us to the great ethical question of our age. By sending out these ships, are we propagating our species, or are we condemning our descendants to an existence of utter and absolute isolation? Each new colony is an act of abandonment. We are creating orphans of time, sentencing them to lives where their only connection to their ancestors is a flickering, delayed image from a long-dead world. The human family has been irrevocably broken. We are a diaspora, not of space, but of time itself. A species scattered into countless disconnected histories. Perhaps this is the cost of the cosmos. But it is a cost so high, it makes us question the value of the prize. And yet the universe has another lesson for us. A lesson in humility, delivered on a scale that beggars imagination. We believed FTL travel would make the universe manageable, knowable. We could finally chart it, map it, understand it in its totality. This was our greatest act of hubris. Even with the ability to cross a galaxy in a year, the universe refuses to be contained. The observable universe is 93 billion light-years across. To cross it, even in our fastest ship, would take longer than the current age of the universe itself, and that is only the part we can see. The cosmos beyond that horizon could be trillions of light-years across, or it could be literally infinite. We have unlocked a door only to find ourselves in a hallway that stretches into eternity. The numbers are so vast, they become a form of madness. 2 trillion galaxies in the observable universe alone, each with hundreds of billions of stars. Take a single grain of sand, that is a star. All the grains of sand on all the beaches of Earth, that is not even a fraction of the stars in our own Milky Way galaxy. Now imagine more galaxies than there are grains of sand on our entire planet. Our FTL drive, our miracle engine, allows us to travel from one grain of sand to another very, very slowly. The sheer, overwhelming scale of it all remains. It crushes our ambition. It mocks our technology. But the problem is deeper than just size. It is a paradox of knowledge itself. The universe is not a static object waiting to be catalogued. It is a dynamic, evolving entity. And light, the carrier of all information, is slow. When we look at the Andromeda Galaxy, we see it as it was 2.5 million years ago. The light from the most distant galaxies we can detect has been traveling for over 13 billion years. We are seeing them as they were in their infancy. We thought FTL travel would solve this. We could go there. We could see what that galaxy looks like now. But when we arrive after a journey that might take centuries, that galaxy is centuries older than when we left, and the one we departed from is now centuries in the past. We are forever trapped in a state of catching up. We arrive at the scene of a cosmic event billions of years after it has concluded. Our exploration is nothing more than cosmic forensics. Sifting through the ancient ruins of galactic history, we can never, ever know the universe as it is. We can only ever know it as it was. The now we sought to unify across the stars is a phantom, an illusion that shattered the moment we tried to grasp it. This is the ultimate intellectual awakening, the great revelation granted to us by our impossible machine. The purpose of our journey cannot be to map the whole. It cannot be to know what is. That is a fool's errand, a goal for gods, not for mortals. The universe in its totality is and will forever remain unknowable. Our relationship with the cosmos had to change. We are not its masters. We are not even its explorers. We are simply its inhabitants. Brief, conscious moments allowed a fleeting glimpse of an infinitesimal corner of an infinite expanse. Our technology did not shrink the universe. It simply provided us with a more profound and humbling metric by which to measure our own insignificance. And in this newfound humility, we confront the final and most important question of all. Who are we in this new cosmos? What is our responsibility? For millennia, we have looked at the silent stars and asked, are we alone? The Fermi paradox. If the universe is so vast, where is everybody? We assumed the great silence was a riddle of distance. That other civilizations were simply too far away to hear or to reach. But with FTL, travel distance is no longer the barrier. We can go to these worlds. We can visit the billions of Earth-like planets we have detected in our own galactic neighborhood. We can knock on the door and see if anyone is home, and so the great silence transforms. It is no longer a question of physics, it becomes a question of ethics. What if we are the first? What if, in all this terrifying immensity, our small, fragile consciousness is the only thing of its kind to have yet arisen? The responsibility is staggering. We become the custodians of mind in a mindless universe, the bearers of a flame so rare it might be unique. Every new world we touch must be treated with a reverence bordering on the sacred. An alien microbe, a simple strand of non-terrestrial proteins, would be the most profound discovery in history. A discovery we could instantly annihilate with our own biology. We must become ghosts observing from afar our very presence, a potential act of cosmic vandalism. But then there is the other possibility, the more chilling one. What if we are not the first? What if the great silence is not an absence of life, but a deliberate choice, a choice made by countless other civilizations that reached this same technological precipice? Perhaps they discovered the same paradoxes we did. They learned that FTL travel shatters causality, dissolves identity, and unravels the very meaning of civilization. They understood that to use such a power is to play with the fire that burns down the structure of reality. And so they chose to stay silent. They chose to stay home, to nurture their own worlds, to explore inner space rather than a treacherous, paradoxical outer space. The great silence then is a warning, a quarantine sign hung on a galactic scale. It is the collective wisdom of our elders whispering across the void, "Do not make the same mistake we almost did." Some doors are meant to remain unopened. This is the final sobering truth, the ultimate climax of our quest. We built a machine to escape our cradle, to break our chains, but all it did was reveal a new set of walls. Not walls of space and time, but walls of consequence, walls of logic, walls of responsibility. The universe did not become our playground. It became a profound moral labyrinth. Our great journey outward has forced us finally to look inward. It has held up a mirror to our species. It has asked us not what we can do, but what we should do. Faster than light travel gave us the power of a god and the wisdom to be terrified of using it. It taught us that true mastery is not about conquering the exterior world, but about understanding our own interior one, our place within the whole. We learned that we are not and can never be the rulers of this reality. We are its children, and like all children, we have rules to follow, laws that are far older and more profound than the mere speed of light, laws of cause and effect, of identity and legacy, of humility and of awe. The journey to the stars, it turns out, was never about the destination. It was about discovering the fundamental nature of the journey itself, and realizing with a quiet and final reverence that the most important universe we have to explore is the one that lies within. And so our journey ends. The impossible voyage concludes not with a triumphant arrival at some distant alien shore, but with a gentle return to the quiet reality of the present. The clock, which had been so violently distorted, so mercilessly warped by our thought experiment, begins to tick again with a familiar, steady rhythm. The starlight that was a lethal blue-shifted torrent once more becomes a serene canopy of distant ancient suns. We are home. We are here now, bound by the same immutable laws that we so boldly attempted to defy. The ultimate velocity remains forbidden, a sacred limit etched into the fabric of space-time itself. You cannot travel at the speed of light. It is the most resolute and unyielding law we have ever discovered. To even approach it is to flirt with infinity. Your mass would swell towards the immeasurable, demanding all the energy that has ever existed in the cosmos to push you just one fraction closer to that final absolute barrier. It is not a technological problem waiting for a clever solution. It is a wall of pure mathematics, a fundamental truth about the relationship between matter, energy, and time. The universe, it seems, has a speed limit, and it guards that boundary with the power of infinities. But even if some unknown physics allowed us to circumvent this, to somehow bypass this cosmic decree, we confronted a truth far more devastating: the paradox of time, a cruel cosmic joke played on the aspiring traveler. To journey forth at nearly the speed of light is to receive a one-way ticket to the end of all you know. Your clock would slow to a near standstill, while the universe outside your vessel hurtled onward through the ages. A trip of a few years for you could mean 10,000 years for Earth. You would arrive at your destination, a ghost from a forgotten past, a relic of a civilization that has long since crumbled to dust. You could see the future, but never your own. You could reach the stars, but you would lose your world. The price of the ticket is everything you have ever loved. It is a journey of absolute and irreversible exile. And then there is the raw physical violence of the cosmos itself. At such velocities, the universe transforms from a vast, placid vacuum into a treacherous, lethal shooting gallery. Every stray hydrogen atom, the most common substance in existence, becomes a high-energy particle, a microscopic cannonball. Your ship would be sandblasted by a relentless storm of radiation, each impact a tiny burst of gamma rays, slowly but surely tearing apart your vessel, your electronics, and the very molecules of your own body. Space is not empty. And at light speed, that simple fact becomes a death sentence. The dream of flitting between stars as easy as crossing a room collapses under the sheer weight of physical law. It appears to be a closed door, a final definitive no. So you might ask, why did we take this journey at all? Why indulge in a fantasy that reality so thoroughly rejects? Why spend our time contemplating an impossibility? Because the value was never in the destination. It was in the asking of the question. The thought experiment, the act of pushing an idea to its absolute limit, is one of the most powerful tools we possess. It is a probe we send into the deep unknown, a vessel of pure imagination dispatched to test the very foundations of what we believe to be true. Our attempt to theoretically break the light-speed barrier did not succeed in breaking it. Instead, it revealed to us the sublime and elegant structure of the very laws we sought to overcome. It was in contemplating this impossible velocity that Einstein was forced to tear down our classical intuitive reality and replace it with something far stranger and far more profound. He revealed a universe where space and time are not separate and absolute, but a single interwoven flexible fabric spacetime. He showed us that mass is a frozen form of concentrated energy bound together by the most famous equation in history. He unveiled the secrets of time dilation and length contraction ideas, so counterintuitive they sound like madness, yet they are confirmed every single day in our particle accelerators. The impossible question did not give us a starship. It gave us the theory of relativity. It gave us a new cosmos, a new understanding of existence itself. It was a key that unlocked a room we never even knew existed. The lure of faster-than-light travel continues to do this work today. It continues to push the boundaries of theoretical physics. When scientists speculate about warp drives like the Alcubierre concept, they are not seriously drafting blueprints for a new engine. They are stress-testing the limits of general relativity. They are asking, what does the mathematics allow? Can space-time be bent, warped, and folded in such a way as to create a loophole in the cosmic speed limit? Could a theoretical vessel ride a wave of space-time itself, arriving at a destination faster than a beam of light could cross the gap, all without locally breaking any physical laws? The current answers lean towards no, requiring exotic matter with properties we have never observed and may not exist. But in asking, we learn more about the nature of gravity, the properties of negative energy, the quantum foam, and the very stability of the universe we inhabit. We are cosmic cartographers of the impossible, and by mapping its shores we chart the true shape of the possible. The same is true for the concept of wormholes, those hypothetical tunnels through the fabric of reality. Considering these shortcuts, these Einstein-Rosen bridges, forces us to confront the deepest questions about the topology of space, the nature of black holes, and the unsettling possibility of closed, time-like curves of paradoxes that could unravel causality. These ideas, born from the desire to cheat distance and time, become invaluable intellectual tools. They are the whetstones upon which we sharpen our understanding. The impossible question is not a dead end. It is a catalyst. But the value of this dream extends far beyond the equations of physics. It reaches into the core of who we are. The yearning for light speed is not just about exploration. It is about transcendence. It is a profound, almost spiritual desire to overcome our limitations. We are fragile, ephemeral beings confined to a single planet that is itself a microscopic speck in a staggering cosmic ocean. We live for a fleeting moment on a timescale of billions of years. The distances between the stars are so vast that they mock our lifespans, our ambitions, our very significance. To travel at the speed of light is to defy that insignificance. It is a dream of escaping the solitary confinement of our solar system. It is a dream of outrunning death itself, of reaching a state where time, our great adversary, loses its power. It is the ultimate expression of the human spirit's rebellion against its own perceived smallness. This question forces us to look in the mirror. What does it mean to be human in a universe so immense? Are we defined by our physical boundaries or by the boundless reach of our curiosity and imagination? Science fiction, so often dismissed as mere fantasy, plays a critical role in this exploration. It is the laboratory of our collective dreams. It is where we build these impossible ships in our minds, where we journey to these unreachable worlds, and where we confront the philosophical and ethical dilemmas that such journeys would entail. Imagination is the vanguard of discovery. Before the Hubble telescope showed us pillars of creation, artists dreamed of cosmic clouds where stars were being born. Before we knew of exoplanets, writers populated the galaxy with 1 billion strange new worlds. Before the equations of relativity were ever written down, human beings simply looked up at the night sky and asked the most powerful, most creative, most important question there is: what if? What if we could go there? What if we are not alone? What if the rules are not what they seem? This thought experiment, our journey to the speed of light, reminds us that our greatest voyages may not be physical. The most profound discoveries in our history were not made by traveling to a new place, but by seeing the same place in a revolutionary new way. Newton did not travel to the moon to discover gravity. He saw an apple fall and extended that simple observation out into the heavens, connecting our world to the cosmos in a single law. Darwin did not need to see evolution happen in real time. He observed the subtle variations in life on a small group of islands and saw in them the grand, sprawling story of all life on Earth. Our most powerful vehicle for exploration has never been a rocket. It has been the human mind. And that vehicle has no speed limit. It can leap across galaxies in an instant of insight. It can travel back to the dawn of time through the language of mathematics. It can peer into the subatomic realm, a universe within ourselves, and witness the quantum dance that underpins all of reality. So we cannot travel at the speed of light, but we have built machines that can. Our radio telescopes collect light that began its journey long before our species even existed, allowing us to witness the birth of galaxies. The Voyager probes, our silent, stalwart emissaries, are now drifting through interstellar space, carrying a message from a world they will never see again. Their journey is slow, patient, and heroic in its own right. They are a testament not to our speed, but to our persistence, to our unyielding need to reach out, even if the reply takes millennia to come back. The James Webb Space Telescope is, in a very real sense, a time machine. It does not travel into the past, but it intercepts ancient light that has been traveling for over 13 billion years, allowing us to gaze upon the first stars and galaxies as they flickered into existence in the cosmic dawn. We are already exploring the universe at the speed of light, just not in the way our science fiction dreams first imagined. We explore not with our bodies, but with our instruments and, more importantly, with our intellect. The real adventure is not about conquering the cosmos. It is about understanding it. And that quest is in many ways far more grand and noble. It requires a different kind of courage. Not the courage to face the physical dangers of deep space, but the intellectual courage to abandon our most cherished beliefs, to embrace ideas that defy our common sense, and to accept a universe that is far more complex, bizarre, magnificent than we ever dared to imagine. It is the courage to admit what we do not know which is the necessary first step to learning anything at all. Our journey at the speed of light has brought us full circle back to the fundamental human impulse that launched it: curiosity, the insatiable, relentless, and sacred desire to know. It is the engine of our civilization, the force that propelled us out of the caves and onto the moon. It is the light by which we navigate the darkness of the unknown. And it is fueled by asking precisely these kinds of impossible questions. We may never build a starship that can reach light speed. That particular dream might forever remain a beautiful fiction. But the act of dreaming it, of striving for it, of wrestling with the laws of physics that forbid it will continue to propel us forward, It will inspire new generations of scientists, engineers, and artists. It will lead to discoveries we cannot yet foresee in fields we have not yet named. Because the greatest barrier in the universe is not the speed of light, it is the failure of imagination. The stars do not wait for us. They feel no urgency. They have burned for eons before we were here, and they will continue to burn for eons after we are gone. Our place in this immense cosmic drama is not to outrun them, but to find our own meaning in their silent, majestic presence. The greatest discoveries are still out there waiting, not in distant galaxies, but in the unanswered questions, in the daring hypotheses, in the thought experiments yet to be run. Our voyage is far from over. In many ways, it has only just begun, and it will continue as long as we have the audacity to look up at the vast, silent, star-dusted night and dare to ask the most impossible questions of all.